Every year on 22nd December, National Mathematics Day is celebrated to mark the birth anniversary of legendary Indian mathematician Srinivasa Ramanujan and his contributions in the field of mathematics. Our former Prime Minister of India, Dr. Manmohan Singh, paid tribute to Srinivasa Ramanujan at a function organized on the occasion of the 125th birth anniversary of the great Indian mathematician Srinivasa Ramanujan Iyengar in Chennai in 2012 and declared 22nd December as National Mathematics Day. Let us now look into the life of Srinivasa Ramanujan.
Srinivasa Ramanujan was born in 22nd December 1887 in Erode, a small village in the southern part of India. Shortly after his birth, his family moved to Kumbakonam, where his father worked as a clerk in a cloth shop. Ramanujan was a child prodigy and a mathematical genius. Ramanujan possessed an incredibly amazing intuition of numbers, fractions, and infinite series. He turned out a huge number of significant and complex results largely based on intuition. He mingled with argument and induction. When at age 15, he opted an outdated book called A Synopsis of Elementary Results in Pure and Applied Mathematics. Ramanujan studied 5,000 theorems in that book before he made formulated theorems on his own. By the end of his school life, he obtained a scholarship to a college in Kumbakonam. Seeking the help of the members of the society in 1912, Ramanujan was able to secure the post of a clerk in Madras High Port Trust. At the Port Trust, he was able to make a living by building a reputation for himself as a gifted mathematician. Around this time, Ramanujan had become aware of the work of British mathematician G. H. Hardy, who himself had been something of a young genius, with whom he became a correspondent in 1913 and shared some of his work. Hardy convinced Ramanujan to come study with him at Cambridge University during the subsequent 5-year mentorship. Ramanujan was awarded a Bachelor of Sciences for research in Cambridge in 1916, and in 1918 he became a member of the Royal Society of London. Ramanujan made many contributions to mathematics, especially the number theory. Much of his work, including the number theory, was done jointly with his mentor, Professor G. H. Hardy. A biography of Ramanujan titled The Man Who Knew Infinity was published recently. Years of hard work, isolation, and exposure to cold, wet English climate in 1917, he eventually contracted tuberculosis. After a brief period of recovery, his health wasn't in good condition and it started deteriorating. In 1919, he returned to India to spend time with his family. Srinivasa Ramanujan passed away on 26th April 1920 at the age of 32, and even on his deathbed had been conceived by math, writing down a group of theorems that he said had come into him in a dream. On this special day, let us all remember Ramanujan's contribution to the world of mathematics. Happy Mathematics Day. Thank you.
Hello, Ramanujan. How are you feeling now?
Not very much, but I really want to finish what I started.
There's a great news for you. You've been elected as a member of the Royal Society.
Thank you, thank you. It's really great news. I am always fascinated about numbers. I feel each number is very unique.
Well, Ramanujan, I want to tell you something. The cab in which I came was numbered 1729. That's a dull number.
729? That's an interesting number. It can be expressed as the sum of two cubes in two different ways. It can be expressed as 1 cube plus 12 cube and also as 9 cube plus 10 cube.
Great, Ramanujan. You're really a genius in the world of mathematics.
Thank you, Hardy.
Mathematics is not about numbers, equations, computation, or algorithms. It is about understanding. A famous quote by Srinivasa Ramanujan. Hello everyone, my name is Elena from grade 5 Daisy. Today I am here to show you a trick with magic numbers using a calendar. Let's see how the trick works.
Here we have a calendar of November 2021. Now we will have to select a square anywhere in the calendar. That is, we have to select equal number of rows and columns. Let's select a square with 4 rows and 4 columns. Here we have selected a square. As we can see, it has 4 rows and 4 columns. Let's zoom the square so that it will be easy for you to understand. Now we have to select a number from the square. First, we will select number 5. We will put a circle around number 5. Now we have to cross every other number coming in the row and column of number 5. Let's cross it one by one. 4, 3, 2, 12, 19, and 26. Now we have to select another number. Let's select number 17. Now we have to cut all the other numbers in the same row and column. Now select next number. Let's go with 25. Now cross the numbers. Let's circle the remaining number, that is 9. Now we have to add all the circle numbers together. That is 5 plus 25 plus 17 plus 9. The total is 56. And the trick is we will get the same total for whichever number we select in the square. Let's play with another set of numbers. First, let's go with number 2. Then number 18. Then number 12. And round the last number 24. Now let's add the numbers. 2 plus 18 plus 12 plus 24. Total is again 56.
You can continue playing by selecting different numbers, but the total of the numbers will be the same. This number is called the magic number. Maths is always fun and interesting. We can play with numbers using maths tricks to fascinate our friends and families. Hope you all like this trick. You should definitely try this at home. Thank you.
Hello everyone, I am Gayatri Harikrishnan. Do you know which is the queen of all the sciences? It's maths. Maths is everywhere. Learning maths is too much fun. On this Mathematics Day, I am going to sing a song about maths. Math is magic. Math is magic. Learning math is fun. Learning math is fun. Math is queen of sciences. Math is queen of sciences. Math is always true. Math is always true. Addition and subtraction, multiplication and division. Interesting topics. Math is very interesting. Math is very exciting. I love maths. Math is very interesting. Math is very exciting. I love maths. Let's learn with joy. I love maths. Let's learn with joy. I love maths. Let's learn with joy. Happy Mathematics Day. Thank you.
Good morning all. We students of grade 4 Daffodil present here a skit on the importance of mathematics in our daily life. Good evening, Dolly. How was your day?
Sorry to say, Father, nothing was good. My math teacher always says, try, try, try. Practice, practice, practice. But I feel boring and want to cry, cry, cry. But every day, I don't need it. Without it, I want to achieve my goal.
Don't say that. Math is very important in day-to-day life. It is a part of our life.
No, it is not a part of my life.
Okay then, what can I say now? You will understand it one day.
What is the time now? How can I say the time? You don't need maths in your life, and without numbers, I cannot say the time. I'm sorry. You silly clown. Go away. I'll ask my mother. Oh no, this noodles is not tasty. It is salty. How can I eat this?
This is your decision. It's not my fault because you didn't want to use correct proportion because you don't need maths. I'm sorry. You can have this now.
Okay, I don't want to eat. Today there is drawing competition in my school, Father. Let's go and buy some colors. These colors are good. I will take this.
Money, money, money. I am money. Without me, you cannot buy anything. To know the value of that colors, you need to calculate. That is math, but you don't need math. There is no place for me in your life. So, I am going. You will not get your colors.
Dear friends, now I understood that math is everywhere. It is very important in our daily life. Without math, we will not survive.
So, dear friends, math is having a solution to all our problems. Hope you enjoyed the skit. Thank you.
Happy Mathematics Day! On this special day of celebrating the dedicated life of Ramanujan, I am Pratana Balakrishnan of grade 6 and today I am going to explain to you about Ramanujan's magic square. Okay, so do you know the relation between this magic square and Ramanujan? Check the first row. So it's given as 22, 12, 18, 87. So what is this 22, 12, 18, 87? It's actually Ramanujan's birthday, which means his birthday is on the 22nd of December 1887. Now let's see the magic behind this magic square and how he created it. So look at this formula. So it's given as D, which stands for date, M standing for month, 100 which is H standing for hundreds. You can also use C, which stands for century, and then Y standing for year. So look, Y plus 1, which means year plus 1. So 87 is the year and we have to add that with the number 1. So we get 88, right? Next, H minus 1 or 100 minus 1. So 18 minus 1 gives 17. Next, M minus 3 or month minus 3, which is 12. December, which is 12 minus 3, which is equal to, yes, 9. Next, D plus 3 or date plus 3, which is equal to 22 plus 3, which is 25. Okay. Next, month minus 2. Month minus 2 means 12 minus 2, which is equal to 10. Then D plus 2. D plus 2 means 22, which is the date, plus 2, which is equal to 24. Next, y plus 2 or year plus 2. We have 87 as the year. We have to add 2, which will make it equal to, yes, 89. Then h minus 2, hundreds minus 2. So 18 minus 2, which is equal to 16. Very good. Next we have hundreds plus 1. So 18 plus 1 will be equal to 19. Then we have y minus 1, which is equal to, yes, 87 minus 1, 86, sorry. Then we have d plus 1, date plus 1. So that means 22 plus 1, which is equal to, yes, 23. And lastly, we have m minus 1. What is m? Month. M minus 1. So 12 minus 1, which is equal to 11. So what really is this magic behind this magic square? Yes, you have to know this. So when you add every row and when you add every column, even if you add the diagonals or the little squares like these middle squares or the corners, you will be getting the number, a prime number, which is 139. Okay, so you will be getting 139, which is Ramanujan's magic number, which he found out using his birthday numbers and creating this magic square. So you can also create a magic square just like this using your own magic numbers and using this formula. So I hope you enjoyed this presentation. I hope you learned a lot about this magic square. Please try. Thank you.
Good morning, dear friends. Today, on this Mathematics Day, we, the students of grade 4, would like to present a skit. The name of the skit is Zero is Hero. One day, a great mathematician wanted to meet the numbers. So, he arranged a meeting with the numbers. Now, let us see what happens.
Hello numbers. Today we have a meeting. Come and stand here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Someone is missing. It's 0. Where is 0? 6, 7 and 8. Go and find him. Huh? Why are you crying and hiding? Come on, 0. Why are you crying? There is a meeting. Come. What's happened? Why are you crying? All the numbers are teasing me and saying I have no value. It's not that. Let me explain. It's not that. 1, come here. Stand here. What is the value of 1 now? Still 1. 0, come and stand here. What is the value of 1 now? Now it is 10. If I add 1 more 0, what is the value of 1 now? It is 100. So it means that 0 makes number even bigger. What is the value of 9? 9 itself. 0, come here and stand here. What is the value now? It's 90. Okay, now I add 1 more. What is the value now? It is 900. So it means 0 makes number even bigger. Even bigger. Who is the hero now? 0. Every number has value and every person in this world has value. When 0 stands in the left of a number, it has no value. But when it stands in the right of the number, it has value. Because 0 makes the number bigger, so 0 is the hero. Thank you.
Hello everyone, I'm Jatiswaran here from Grade 6 Bluebells. To commemorate the birth anniversary of the mathematician Srinivasa Ramanujan, I present a poem. Mathematics is full of fun, like playing in the seesaw, up and down. Different equations running through my mind. Oh, math, why can't I understand? Math, oh math, please do social distancing. We shall return like Martin Luther King. we can't meet and touch between integer signs because remember, you and I are parallel lines. Math is a beautiful mystery. It is everywhere, they say. Beautiful mystery seen beyond the sky. A mystery waiting to be deciphered aesthetically. Mathematics taught me how to solve. Solutions that taught me ways to survive. Solving different problems with different solutions, helping me correct my misconceptions. Math is a challenge that is full of mystery. Discovering new methods in math history, learning is a never-ending process in life. So, solving math is like me to solving my life. Math, how can you be so beautiful? Teaching me things I thought never would be useful. Math, it is not easy to understand you, but you coming to our life is helpful. So, thank you.
Everyone, I'm Aisha of grade 5 Aster. So today I'm going to show you about fractions. After watching this full video, you'll be understanding about fractions. So let's get to the materials required for this activity is 2 art paper, then a roller, a sketch pen, a scissor, and a compass and a pencil. So now we can draw a circle with a compass. Now we need to cut the circle. So now we had cut the circle. Now we need to cut it again in another art paper. Now we had cut both the circles. Now we need to draw a line with a sketch pen or a marker. So we can draw it. We need to divide it into 4 shapes. Now we need to cut it from here to here. We should only cut till here. So we had completed. We need to do the same over this. Now we need to keep this circle into this circle. Like this. Now we can learn fractions. So this is 1 by 4. Now this is 2 by 4. Now this is 3 by 4. And this is 4 by 4 or a whole.
From grade 5 DC. Here I'm going to show you how to make the sieve of Eratosthenes. It is created by the Greek mathematician Eratosthenes and it is an ancient method used to find prime numbers in an array. So let's begin. For that, in a chart paper I have drew some columns. Next in this I'm going to write the numbers from 1 to 100. To make it more sense and attractive, I'm going to color it. For 1, I have colored it blue as it is neither prime or composite. I have colored red for composite and green for prime numbers. So the code here is blue represents neither prime or composite, green represents prime numbers and red represents composite numbers. Sieve of Eratosthenes is red. It's very easy and simple, also helpful. Thank you.
Come and join our mathematics class. You will be surely enjoy being here with us. Mastering basic facts, multiply and divide, and then all being learned in easy way. Solving problems in so many ways. Number sentences are easy in any way. And with easy techniques makes us do our best. Modern math today is just the best for us. We're on the top of the world solving. Down on the land of numbers, learning concept by discovering. It's the love that we found from the very, very start. Come be happy and have fun in our class.
Hi, my name is Aniket, and today we are going to talk about the properties or rules of exponents. Before going into that, we are going to see what is an exponent. If a non-rational number a is multiplied a into a up to n times, then it's an exponent. Here, a is the base and n is the exponent. Now let us go into the rules. Firstly, we have the product rule. According to this rule, a raised to m into a raised to n is equal to a raised to m plus n. Let us take an example. 2 raised to 2 into 2 raised to 3 is equal to 2 raised to 2 plus 3, that is 2 raised to 5. Next, let us go into the quotient rule. This rule states that a raised to m divided by a raised to n is equal to a raised to m minus n. Let us understand that easier by taking an example. 2 raised to 3 divided by 2 raised to 2 is equal to 2 raised to 3 minus 2, that is 2 raised to 1. Next we have the power rule. According to this rule, a raised to x the whole raised to y is equal to a raised to x into y. Let us take an example. 2 raised to 3 the whole raised to 2 is equal to 2 raised to 3 into 2, that is 2 raised to 6. Next we have the easiest one, the zero exponent rule. According to this rule, a raised to 0 is equal to 1. Let us take an example. 2 raised to 0 is equal to 1. Next is the negative exponent rule. According to this rule, a raised to minus x is equal to 1 by a raised to x. Let us take an example to understand this easier. 2 raised to minus 3 is equal to 1 by 2 raised to 3. And the last but not least, the power of fraction rule. According to this rule, a by b the whole raised to x is equal to a raised to x divided by b raised to x. Let us illustrate this with an example. 2 by 3 the whole raised to 2 is equal to 2 raised to 2 divided by 3 raised to 2. This was all about the properties and rules of exponents. Thank you.
To one and all, my name is Mridul Matthew Joseph and I am from grade 8 Lotus. Today, I am here to demonstrate an activity about linear equations. Let us imagine that the big circle is x, the semicircle is x by 2 and the quarter circle is x by 4. We'll also imagine that the white point means -1, the black point means +1. When we add the black point and the negative point means 1 and -1, which equals 0. Now we'll move on to some examples on linear equations. The first one is x plus 3 equals 4. Since we have assumed the big circle to be x, I'll bring this here. Since there is plus 3 given, I'll add 3 positive points. And since there's 4 here, I will add 4 positive points on this side. Now, to balance this, we need to get rid of the 3 positive points on this side. So, I'll add 3 negative points on this side. Since we know that +1 and -1 equals 0, each of these cancels each other. +1 -1, +1 -1, +1 and -1. But since we have put 3 negative points on this side, we have to add 3 negative points on this side as well. Now we have a complete solution to the problem which says x equals 1. So our answer is x equals 1. Now let us move on to the second example. X by 2 equals 3. Since we have assumed the half circle to be x by 2, we'll bring this here. Since there is +3 on this side, I'll add 3 positive points on this side. Now, 2 semicircles make one circle, and since we have assumed the circle to be x,
We'll add another semicircle to make X. Now since we have doubled the amount on this side, we have to double the amount of pawns on this side as well. Now we have a complete solution to the problem which states that x equals 6. So our answer is x equals 6.
Hi all, my name is Arshida Ramesh. I am studying first grade Buttercups. I am singing a song, Shapes. Do you know what I am? Say my name if you can. I have just one line, goes round and round. I have wrote on the ground what I am. You are a circle. Do you know what I am? Say my name if you can. If you look 3 sides, 1, 2, 3. 1, 2, 3. What I am? You are a triangle. Do you know what I am? Say my name if you can. I have 4 sides. They are all the same. If you know me, you are good at this game. What I am? You are a square. Do you know what I am? Say my name if you can. I have 4 sides. My 2 sides are shorter. And I don't care what I am. You are a rectangle. Draw a circle in the air. Draw a triangle in the air. Draw a square in the air. Draw a rectangle in the air. Sheep. I see sheep. Everywhere I found, I see lots of sheep. Circle. Square. Triangle. Rectangle. Sheep. I see sheep. Everywhere I found, I see lots of sheep. Thank you.
Hi everyone. As we all know that December 22nd is celebrated as National Mathematics Day across the nation to recognize and celebrate the works of the great Indian mathematical genius Srinivasa Ramanujan. Today I am going to calculate the area of trapezium with the help of an activity. In a sheet of A4 size paper, draw a trapezium ABCD. Trapezium is a quadrilateral with one pair of parallel sides. Let side AB be A, which is equal to 9 cm. Let side CD be B, which is 6 cm. The perpendicular distance between AB and CD or the height of the trapezium be H, which is 5 cm. Draw another trapezium PQRS, which is identical to trapezium ABCD. I gave blue color to trapezium ABCD and red to trapezium PQRS. Now cut out both trapezium from the paper. Then we will get 2 identical trapeziums. Then arrange the trapezium in the form of a parallelogram. Turn the red trapezium upside down and keep it next to the blue trapezium. Now we can see that the parallelogram is formed. Now the length of base of the parallelogram is A plus B and height of the parallelogram is equal to height of trapezium, which is H. This parallelogram is formed by 2 trapeziums. So area of parallelogram is equal to 2 into area of trapezium. Therefore, area of trapezium is equal to half into area of parallelogram, which is equal to half into A plus B into H. That is, area of trapezium is equal to half into sum of parallel sides into height. Thank you.
We are going to solve the magic square problem with the help of Srinivasan Ramanujan's general formula to find the magic square. To write the formula, we need a square which has 3 columns and 3 rows. He has given some formula with alphabets, and we are going to give values to these alphabets, and they can be any random number from 1 to 9. And there are 9 cells, 3 columns and 3 rows in a square. I have given A1, B2, C3, P4, Q5, R6. Now we are going to assign these numbers into the column and row. C plus Q I have given 3 plus 5. A plus B I have given 1 plus 4. B plus R I have given 2 plus 6, and so on. Then I have I did the sum and wrote it like numbers. That is 3 plus 5 is 8. 1 plus 4 is 5. 2 plus 6 is 8, like that. Now when it comes to adding the horizontal, in the horizontal way, in the vertical way and the diagonal way, the answers will come the same itself. Let's have a look. 8 plus 5 plus 8 gives 21. 7 plus 7 plus 7 gives 21, and the same over here also. In the vertical way, 8 plus 7 plus 6 gives 21. 5 plus 7 plus 9 also gives 21. 8 plus 7 plus 6 also gives 21. And when it comes to the diagonal way, 8 plus 7 plus 6 gives 21, and 8 plus 7 plus 6 also gives 21. So you can see how easy it is to find the magic square with the help of Srinivasa Ramanujan's formula. Thank you.
Hello everyone, my name is Vaishnavi P. I'm from grade 7 Marigold. Today we are going to learn 3 number tricks. So let's get started. First, I'm going to choose 21 and 31. So how do we multiply these 2 numbers? Well, there is a simple trick. First, we need to multiply 2 and 3. So 2 into 3 is 6. Now we have to leave a space after 6. Then we need to multiply 1 and 1. So we'll get the answer as 1. Now for finding the digit in the tens place, we need to multiply 2 into 1, which is 2, and 1 into 3, which is 3. Now we need to add 2 and 3. So the sum of 2 and 3 is 5. So we got the answer as 651.
Hi all, I'm Anova Aidur, currently studying in grade 9 Oleander. As we all know, today, 22nd December, is the birthday of one of our greatest mathematicians, Srinivasa Ramanujan. His birthday is celebrated as National Mathematics Day in India. On this occasion, I am going to tell you some tricks in Vedic mathematics. Vedic mathematics is a collection of techniques to solve mathematical arithmetics in an easy and fast way. Vedic mathematics is a system of mathematics which was discovered by an Indian monk, Bharati Krishna Tirtha Ji, in between 1911 and 1918. Later, his findings was published in the form of a book called Vedic Mathematics in 1965. It It consists of 16 sutras or formulas and 13 sub-sutras. It consists of formulas to solve problems in geometry, algebra, arithmetic and calculus. So let's look at each steps in solving problems in Vedic mathematics. So first, let's try to find the product or this product of any number which is below 100 with 11. So let's take an example of 11 into 16. So the first step is that we have to take the number with which we are multiplying 11, that is 16, and split it into 2. Which is 1 and 6. And the middle value of the product of 11 and 16 will be equal to the sum of the digits of 16, which is 1 plus 6, so it will give us 7. So the product of 11 and 16 will give us 176. So let's try another example with a large number. This is 11 into 78. So here we take 78 and split it into 2, which is 7 and 8. And take the sum of 7 and 8, which will give us 15. Here, since the sum of 7 and 8 is more than 10, we take 1 and add it with the first digit and 5 and put it in the middle digit. And this answer, after we take the sum of 7 and 1, we'll get it as 858. So the product of 11 and 78 will give us 858. So this was the method to do multiplication of any number which is less than 100 with 11. So next we can do a trick to find the product of two numbers which is less than 100 but really near to 100. Let's take an example of 98 into 97. Here we take the base number as 100. 98 is 2 less than 100. So we write minus 02, and 97 is 3 less than 100. So we write minus 03. So the last two digits of the product of 98 and 97 will give us the product of 2 and 6, which will be 06. The next step which we have to do is cross subtraction of 98 and 3 and 97 and 2. Both answers will give us 95. So the product of 98 and 97 gives us 9506. So let's try another question. 92 into 94. 92 is 8 less than 100. So we write 08, and 94 is 6 less than 100. So we write 06. And the last two digits will be the product of 8 and 6, which will give us 48. And we have to cross subtract 92 and 6 and 94 and 8. Both will give us 86. And so the answer of the product of 92 and 94 will give us 8648. So this was an easy trick to do multiplication of numbers which is below 100 but very near to 100. So next we can do the multiplication of numbers which are more than 100 but really near to 100. For example, 101 into 103. Here again we take the base number as 100 and the 101 is 1 more than 100 and 103 is 3 more than 100. Here the last two digits of the product of 101 and 103 will be the product of 1 and 3, which will give us 03. Now, in the previous case, we did cross subtraction, but in this case, we do cross addition. which is 103 plus 3 and 101 plus 3 and 103 plus 1. Both the answers will give us 104. So the product of 101 and 103 gives us 10,403. So let's try another question. 106 into 109. Here again we take the base number as 100 and 106 is 6 more than 100 and 109 is 9 more than 100. Last two digits will be equal to the product of 6 and 9, which will be equal to 54. When we do cross addition, 106 plus 9 and 109 plus 6 gives us 115. So the product of 106 into 109 gives us 11,554. So this was a method to do the multiplication of any number which is more than 100 but very near to 100. I hope this was informative for you, and thank you and have a wonderful day.